Conic sections, question 3. In a suspension bridge, the shape of the suspension cable is parabolic. To determine the length of cable needed for construction, the equation of the parabola must be determined. Find the equation for the parabolic part of the cable if a bridge has towers 800 meters apart and the lowest part of the suspension cable is 200 meters below the top of the towers. Looking at our bridge, we know the lowest part of our cable is 200 meters and our bridge has a length of 800 meters, and thus either side equals 400 meters. We know that in order to solve for a parabola, we need an equation in the form y equals a times x minus x1 times x minus x2. So we have y equals a times x minus x1 times x minus x2. Using the top of the towers as x-intercepts at 400 and negative 400 meters, substituting these points in for x1 and x2, we get y equals a times x minus 400 times x plus 400. Simplifying the equation, we get y equals a times x squared minus 160,000. Using the lowest point of the cable and substituting its x value of 0 and y value of negative 200 into our equation, it gives us negative 200 equals a times 0 squared minus 160,000. Solving for a, we get a equals negative 200 over negative 160,000. So a equals 1 over 800. Substituting a back into the formula, we are able to find the equation of the parabola. Y equals 1 over 800 times x squared minus 160,000. So y equals x squared over 800 minus 200.